So let's start using analytical methods to generally just find out what's the how this graph looks in terms of increasing, decreasing, concave up, concave down. All right, let's start by taking the derivative. Y prime is equal to first times the derivative of the second. The mantra for e to the power of something is same times the chain rule. Please check my work. I mean, maybe it would also be helpful if we would have started out by saying x squared times e to the x to the negative 2 power. Maybe that's a simpler way of writing that expression. Okay, so first times the derivative of the second plus the second times the derivative of the first. And now the trick, both of those terms have an e to the power of 1 over x squared. Pull it out and see what's left over. I've got an x squared. Sorry. Someday my eraser is going to work again.
What day is today?
It worked earlier today. It really did. X squared times negative 2x to the negative 3 is negative 2x to the negative 1 plus 2x. Now the reason why this is a handy thing to do is that we have to find out intervals of increasing and decreasing. We recognize that intervals of increasing and decreasing happen when the derivatives are positive or the derivatives are negative. And this expression right here is always positive. So the only place that you can get a sign change is where this expression goes around. So let's set that part of the expression equal to 0, and then take a look and see if we can find the zeros of that. What's that?
Is it negative 2x to the negative 4?
Well, it was this multiplied by that. These are all, so when I multiply x to the negative 3 times x to the positive 2, I end up with a net negative 1. All right, I think we learned a lesson in the previous problem that I want to think of this as that. And then I'm going to want to find common denominator. Let's multiply this by x over x. And we end up with negative 2 over x plus 2x squared over x. Or 0 is equal to negative 2 plus 2x squared over x. Where are my critical values? 1 at 0. At 0, the derivative is undefined. And the other one is going to be at 1 and at negative 1. Negative 1 squared is going to give me a positive 1. So I've got critical values. I've got values where the derivative may change sign at 0, at negative 1, and at positive 1. And then my question is, what kind of values do we get? Let's start big and negative, really small numbers. If I put a really small negative number, you know what happens here? This turns into 0. Negative 1 million to the negative 1 power. That's 1 millionth. So this thing hardly has any effect when x is big and negative. Everything's coming here, and what do you get? Positive 2 times a negative number. I got a negative way down there. Then what happens? At, let's say, negative 1/2.
Wait, shouldn't it be a negative and positive? Negative becomes positive.
Danielle?
So if you put a negative number to the negative 1 power, it would come
No, I get negative, let's say I put negative 1 million in. That becomes 1 over negative 1 million.
Times negative 2, wouldn't that be positive?
Oh yeah, it'll be positive, but it'll also be really close to 0. It will hardly matter.
You're adding it, though. You're not.
0 plus 2 times.
Okay, think of it this way. Yeah, I get a positive number there. I get 2 over a million. Positive 1 over 500,000. And then the second part is so dominantly negative it controls the situation. Okay, what happens between negative 1 and 0? It's positive. What happens between 0 and 1? And then what happens between 1 and infinity? Positive. So, what does this first derivative table tell us? Well, first of all, the first question is decreasing. Right? Or increasing. Y is increasing on negative 1 to 0 and 1 to infinity. That's part A. Part B. You know, typically we use as a union symbol there. So I'll use that. Y is decreasing on the interval from negative infinity to negative 1, union 0 to 1.
Is there ever a time where you don't put the closed brackets? Besides infinity?
On increasing or decreasing particularly, or
Yeah.
only if the function isn't defined in those places. Oh, you know what? If the function isn't defined in those places. Sarah, say what you're going to say, because I think you'll put it better than me.
0 should be it should be an open interval wherever it's 0 because the function's not defined at 0.
Yeah, if I try to put 0 into my original function, it's undefined there. So yep. So there's the situation where we really should use open. Okay, what's part C? Concave? Concave up, concave down? Okay. So now I have to take the derivative of that. Are you ready? And boy, wouldn't I love to have the eraser work right now. All right.
Just like cross that out.
I want this space to write in. That's my problem.
Next page.
All right.
At least you're not wasting.
Yeah, I suppose we can go to the next page and do this. All right.
Thanks for not wasting it.
So if y prime is e
I heard
to the negative, and this is what?
Negative 2x to the power plus 2x.
Would it be to the negative? Oh wait.
Is that it?
Yep.
All right. So y double prime is going to be first. There's no negative sign there. First times the derivative of the second, which is. Yep. There we go. Derivative of the second is going to be 2 over x squared plus 2.
Isn't it negative 2?
No, because
Well, it was a negative 2 here, and then when I bring the exponent down, it's the opposite of negative. So it ends up being a plus. Plus the second times the derivative of the first. I made the same mistake again. Chain rule. So first times the derivative of the second plus the second times the derivative of the first.
We got the negative 1.
Where's the negative 1 that I missed?
Negative 2x to the negative first power. Negative.
I'm
Yeah, negative third.
I got a negative, right? I bring that power down.
And then you drop.
Oh, and a negative 1 there. Got it. All right.
No, negative 3. Negative 3. Right? Yeah, negative 3.
Where's the negative?
It goes down.
Oh, it goes down. There we go.
We'll give you that one because you're sick.
Okay. All right. In both of these terms, though, there's an e to the negative, e to the x to the negative 2. So I'm going to factor that out. And I've got 2 over x squared plus 2. And then I'm going to distribute this through both of those terms. And I end up with a plus 4x to the negative 4 and a minus 4x to the negative 2. Please check my work. Okay, these two are like terms. And I end up with negative 2 over x squared plus 2 plus 4 x to the over x to the 4th. Yeah? No? And what's our trick here? Common denominator again. So ex to the negative 2, common denominators, so it's going to be negative 2x squared plus 2x to the 4th plus 4 all over x to the 4th. Clean that up just a little bit more.
So that's a 2 now, not a 4.
What's in the red?
That's what I wrote 4, but I should have wrote 2. So it's a 2. Okay, and so the question is, does that top factor? We know that the second derivative is undefined at 0. Does the top factor? Wait. Yeah, use substitution. Let u equal x squared, and we end up getting u squared minus u plus 2. Nope. That doesn't factor. Does it have any solutions?
Does with quadratic form.
Let's go to the quadratic then. U is equal to minus a minus 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 2.
All over 2.
Well, oh yeah, it's all over 2, but take a look at that. I got 1 minus 8 inside the square root. No real answers there. All unreal.
All of this for nothing.
Does
that just mean it's not?
That means there are no concavity changes. Well, sorry. What that means
The real point.
What that means is that we don't have a second derivative equal to 0 anywhere on that. We do have a place where the second derivative is undefined at 0, so let's just sort of finish that off. So if we look at this number line, and we're looking at the second derivative of y, I'm going to ask you, please, when we are to the left of 0, does this expression give us a positive or negative number?
Gives you a positive number. 'Cause
Negative.
isn't easy on
Imagine really, really big and negative numbers going in here. This goes to 0, that goes to 0.
They're both positive.
Imagine putting really big positive numbers in there. So, the answer part, D, C, and D. C is about concave up, concave down, right?
Yeah.
So I would say that it's concave up from negative infinity to 0, union 0 to positive infinity. What about concave down? Never.
That's D.
Yes. It's never concave down. All right. F or E is where our local maximum and minimum. And why? Where did all our writing go? I don't know where our writing went.
Wait, it was
Oh, I graphed it.
Other way around.
negative, positive, negative,
That is
positive.
I know.
Mr. Fedor, if you just graph it, you can get the
Yes, I know that if we graph it, we just get, but it's specified to use analytical methods.
Yeah.
And you have to remember that, you know, half the AP exam, you're not going to have your calculator.
That's cheating.
Will all the problems be like nice and neat, nice and neat numbers?
What do you think?
We'll be like 4 times 4.
I think it's about
I want to do decimals.
this graph. I really don't what.
Not outside, the wrong possibilities.
Can we learn how to do long division?
So, finishing up this problem. If we know that the first derivative does sign changes like this, by the way, we know that also it's undefined here. All we can say is, hey, the first derivative goes from negative to positive there. Therefore, there is a local minimum at x equal -1. Because we go from positive to negative there, we also know that there's a local minimum at +1. I don't know what the value of the function is off the top of my head, but then if you plug that into your equation, you get your information. Yep, it was. Actually, what is it? We can actually calculate it. It's x. Since y is equal to x squared times e 1 over x squared, the value of y at -1 is equal to -1 squared times e to -1 squared, or that's 1 times e or e. And so both of those minimums are e. All right. So that's number 3. Well, it's certainly harder because of